is going to be Mr. Michael Johnson, and he's going to talk about leveraging scientific data to address ways in which to live a healthier life. And that's going to be his presentation for the RET. So let me go ahead on. One more stop and share, and then we're ready to go. Michael, I'll turn it. Here we go. Michael, without further ado, I will turn it over to you. Your time can start now.
All right, many people lack access, information, or ability to make informed decisions about their health. We will discuss some of those barriers and how researchers develop methods and technologies to acquire data to develop useful information to address everyone's health needs. My name is Michael Johnson. I teach AP Computer Science Principles at Challenge Early College High School in Houston, Texas, HISD. I have 11 years of teaching experience, and last year was my first year teaching computer science. So, as far as with the description of the research, first we start with the PRIS-UP's mission. We see that with PRIS-UP, we're really focusing on working on the different wearable technologies, being able to have healthcare access to different ones, and despite whatever population that they're part of, and however, and also to actually influence and recruit other educators. All right, the accomplishments that I achieved was that I was able to be introduced to Python programming. I got an increased understanding of machine learning and classification, and I also collaborated with peers. They helped me with all of our computer science initiatives, everything like that, teaching practices, and also I got a better understanding of how the research process works and different methods and such. All right. So our activities, we utilize breast cancer data sets and packages and tutorials. You see in that first figure. And then we classified breast cancer data. And then that third bullet was I got a lot of assistance from our cohort members. And actually that's some code that I actually borrowed from one of our RAT members, Derek. And he was actually showing us diagramming how the SVM works. And I'll talk about that in just a moment. So talk about different classifiers and everything like that in our. So the personal importance of the project is that actually my grandmother, she actually had breast cancer and she died when I was 12. And so actually being young and not really understanding the whole thing with breast cancer and everything, it was something. And so just understanding that. And also my wife, I did some research and found out that different, if a woman is doesn't have a child, it's like more likely to maybe have breast cancer. So just doing this research helped me focus on that. All right, the highlight for the speaker series. We had three that really were of particular interest to me. We had the PhD student, Ms. Christine Crawford. She had a study on microaggression, and we see that microaggressions are verbal, are behavioral, are environmental indignities, intentional, are conscious. And then we also had the work of Dr. Jessica Ramella and Dr. Ashok, and they talked about the different wearable technologies as well. So our collaboration and remote experience, we first started off when I met everyone was through the C-STAR conference as well. So met everyone, and then we transitioned into the switch, the Summerwell-based Institute, et cetera. And so we have a couple of screenshots of our cohort. You know, they were super helpful. We communicated through Slack, through Zoom. We did some things with Google Docs and everything, and the Google Workspace. And all right, our next thing, we have our lesson development. I'm working with Alonzo Jones in LA. And so we're working on a project. Our lesson is going to talk about like the game Simon. Is Simon Decoded? So we have two phases. So the first phase is that you go through tutorials and learn about what Simon is, and then we actually deconstruct it like physically, and then we go on and we do some programming and coding and we use the Raspberry Pi as well, and then we have the students reflect. All right, and last, my future plans, I actually got accepted into the PhD program in through the College of Information and Learning Technology. So I plan on using this experience to actually grow on my research, to be able to focus. One of my research focuses is that I want to focus on engagement, especially with computer science and STEM initiatives, and just basically just make learning fun for kids. And and for teachers too, so that's really one of my core focuses. All right, the last thing we have, this is my poster on machine learning to detect breast cancer. Again, being a novice Python programmer, this was a huge learning curve, but it was very awesome. We were able to understand the different factors when it comes to like detecting malignant cancer cells, classifying such, and seeing what's the best method to be able to train the computer and to be able to get the results to see which one will actually show us the best way to classify or make a determinant of that such. And so what's next, what I want to do is I actually want to look into some biases when it comes to machine learning. And last but not least, I'd like to thank everyone through the PRIS-UP initiative, Switch, Alan Antoine, all my cohort members, and just everyone for assisting me along this way.
Thank you very much, Michael. We really appreciate it. And obviously you can go ahead on and look at the link with your Jamboard, so you can see some of the kudos that you're getting, a lot of congratulations and things of the sort. But I'm going to touch in on a couple of the questions. The first question I have is, why would you put those pictures of me with hats and looking, I'm dressed up today, you're supposed to do better. But no, actually some of the questions that I see here are really good. One says, what's the most surprising thing about your Switch experience? What surprised you the most about this?
The most surprising thing about the Switch experience was just basically just how deep that computer science is, and just so many different avenues. You think computer science is just like one thing, but there's so many different branches of it and so many different ways that you can teach it to the students. And this, at times it could be overwhelming, which was good because now I was in my students' shoes as well. So, so that was one of the biggest things. And there's so much to learn and just, expand from there.
Thank you very much. Another one says, you mentioned learning Python. What do you usually teach computer science with?
Well, I just did it just stock basic with just code.org. Like I said, being a first year computer science teacher, and we use App Lab, and I actually use a little bit of Snap programming from Berkeley. So, and so the App Lab actually works off of JavaScript. So you can go in between the actual text code as well as the blocks. And so that's what I use in year one, virtual learning and everything. So certain students, they like the blocks, and certain students like the text. And so that's what I use.
Thank you very much. And last but not least, I'll ask you one more question. They said your poster is great. So, we put a lot of hard work in those posters. So great job. But the question is, could you give a short explanation of that graph?
Of the graph?
Yes, sir.
Okay, yeah. So we have the support vector machine algorithm. It yielded the highest results at being at 96.5%. And while this is just a representation, it's not the actual visualization of the actual results from the tutorial. This is just one that shows that how like those different points right there, how they are close enough together, and seeing that they are actually closer to being as accurate as possible through that right there.
All right. Thank you very much, Michael. We definitely appreciate it.